Hello and welcome back to another episode of the Oxford MAT Livestream. It's good to be back. I've missed you all. Good to see everyone in Slido chat, which I can put on screen as well. Actually, it's currently just me in Slido chat. There I am. If you'd like to join in on Slido chat, the place you need to go to is slido.com and use event code MATLIVE if you want to join in with the live chat experience. There, as always, we've got Ginger Biscuit says hello, and Anonymous says good afternoon, which is a reminder to me that you can be anonymous in the Slido chat. That's why we use it. Good to see you. The plan for today is some past paper guidance. It's a little bit different. We've talked about topics, particular maths topics on the show so far, and in the future we're going to look at specific past papers, but I thought we would do this one, which might be a bit of information, and then maybe some Q&A? I don't really know. It's the middle of summer. I haven't done this before. New thing for this year. Right, okay, who else have we got? We've got hello. We've got, oh right, okay, thank you. Slido's explaining to me how to use Slido. Hi Matt, says this person. Is this coming up? Hi Matt, is STEP papers... Okay, so clarification, Matt is the name of my test. My name is James, hello. Is STEP papers good to get my son into Oxford for maths? For maths at Oxford, it is the Maths Admissions Test, MAT. STEP is another thing out there that is another source of tricky maths questions, which you're welcome to use as you're getting ready to do tricky maths questions wherever you might find them, but we don't use STEP. Not directly, but indirectly. Hello, Hugo and Anonymous. And Anonymous again, and Mary, and I missed good afternoon to Jacob. And this thing on the screen says, as well as registering for the test, the thing that's now open is booking for tests. This is a two-stage process that we have over at oxford.ac.uk/tests, which is people for applying for maths or CS or both at Oxford need to not only register for the maths admissions test, but also book a slot. And that has started this week at the time of being live. People are already booking slots to take the test. It seems to be going quite well. So, for example, Anonymous in chat has booked a test, and they get some thumbs ups, presumably from other people who are booking tests. That's an anonymous person here in chat who has anonymously booked a test. Well, I suppose not anonymously for the test booking, but they've booked this as well. Good. Okay. Oh, I'm going to ask you how your day was as well. Let's do that. Does this button do it? Oh, start interaction. What a great thing to click on. Start interaction. I should do that in tutorials, I think. You know, ask a question to the two students I've got sitting there and then press start interaction. You know, time for you to interact. Now. Not before. Right, so that's really tickled me. Is it true, Avni wants to know, is it true we only get 5 unwipeoutable whiteboards for the maths? Kind of, except there's a system for you to request more. So I'm going to disagree with only 5 because you can get more of them. And yes, other people are telling me that the booking was better than booking for other tests that they've booked, and that they've booked a slot for various times. How's the people's day going? Not amazing, 4.2, and somebody's having a 1-star day, which I'm always a bit worried about. Maybe information about tests will be good for you. Sorry, I'm in a new office. I wonder if anybody had already noticed. It's not an exciting background, it's one of my jackets, but it's a different background because I'm in a new office. And the big change, really, for me, is that the camera on this computer, I could move it, I guess, but the camera is in a different place. So I need to look there rather than where I normally look. Right, good. Okay, but at the moment I'm looking over at the poll, which for me is all the way over there. Right, sorry, new question. No, that's fine. Don't apologise. And they now ask, is MAT good to get my son into Oxford? And for maths at Oxford, MAT is basically required. So yes, that's the one that we ask people to do. That's the one that people are booking via this link on the screen. For maths at Oxford, MAT is really the one that we get everyone to do. So basically necessary. Yeah, you get this thing that's a bit like a whiteboard instead of scrap paper. And you can swap the pack of them. These are rules that are partly from Pearson, the way the Pearson Test Centres run as well. Good, okay. Right, what are we up to? Okay, we're asking people how their day was, and that's gone fair enough. I think 4 stars in the end, with really a few 1-star days. I think someone heard me comment about this well, the 1 star day, and other people who have joined in to say they're also having a 1 star day. There you go. Right, how do I stop the interaction? I never want a button really that says stop interaction, but there we go. Yeah, different. It is a different office. I've moved. I'm now in a hexagonal numbered office, but only if you define hexagon numbers. Do people have this? I will do something useful in a second, I promise. My office number is 37 now, which is a very good number. It's a hexagon number because you can arrange 37 dots into a hexagon pattern. Not that many, that was 12. Oh, I've gone a bit wonky. That's 19, and then you go around again and you get 37. So it's a very good number. I'm very keen on the number 37, and it's now my office number, so I'm excited. Is it the same format? Let's get this question out of the way. This is a good. It will turn up on your screen in a second. There it is. Is the format for this year's MAT test the same format as MAT used last year? Yes. You do it in Pearson VUE Test Centre. There are 25 multiple choice questions, 2 long questions. We haven't changed any of the formats since last year. Good. Do I need to register my son to do the MAT? Yes, please. If they're applying for Oxford for 2026 entry for maths, then I guess my advice is look at this page, look at other bits of the website, and ideally, there we go for it. I have no idea what watches you're allowed. Good, right, okay. That sounds, if the person asking about watches, I think that might be a question for Pearson VUE. If your watch is also a calculator, then no, because this is a non-calculator test. But if not, I'm trying to remember. I did. I think I was allowed to wear. I've got. Well, I suppose my watch is the least suspicious watch ever, but I think you can have a watch. I say go for it, and if they make you take your watch off, then the thing has a timer in it as well. You're not required to estimate time remaining. There's a thing on the screen that tells you about time remaining, and if anybody's scared by that fact, you can also hide the thing that says how much time you have remaining. Little clock in the top right corner. If you'd like to try that out, there's a test environment where you can experience what the software might look like, more or less. And that's on the MAT's website. Right. Okay. A watch is not allowed. Jacob's seen some guidelines. Okay. Well, there we go. If your son is going to Oxford in 2030, then not yet. People are registering to do the test this year because they're trying to go to university in 2026. If your son's going to university in 2030, then come back here in 3 years' time, I think. They don't need to register that far in advance. Okay. Yeah, I know. I'm still not going to comment on this one. I'm really sorry. The problem is it's a why question, and there's just some things I'm allowed to say and not allowed to say. We're not going to go there. I'm really sorry. I know people are interested, but the fact is that they are not released. And I'm afraid that's just a fact that we're going to work with. Sorry. Right. Okay. Here's what I want to tell you about today. Jump into me telling you about the MAT. For the rest of the MAT Livestream episodes, before the test, we're going to look at past papers. And I would like to give you some advice about getting the most out of that. I'm referring to, of course, this big table of past papers that we have on the MAT website. If this is news to you, then hooray, there's this big resource of past papers. I've taken a screenshot of it, but you can get the real thing right now. If you go to www.maths.ox.ac.uk/r/mat, and if you do that, then you can get lots of past papers going back to, I think we go back to MAT 2007. People sometimes ask me why we only go back to 2007, and that's because the test changed quite significantly in 2007. There was some sort of test before that, but it was quite different. So my personal recommendation is that that's quite enough maths questions in the maths format. If you want other maths questions, well, I've got some suggestions of other places you might find some maths questions out there. I don't necessarily think that the test from 2006 is like the next best thing if you've done somehow all of the past papers. Well, maybe we'll do that near the end. Right. Yeah, so people are asking in chat about distributing time or something about past papers. Okay. the table contains several things. I'd like to quickly talk through what's in the table and how you might use it. So obviously on the left you'll see there's a column for test paper. That's where you get the questions. We've seen some of these already, especially if you go further back. I've been using those on the MAT Live worksheets that we've looked at so far on the show together. So if you go far back, then you might find that you've already seen some of those questions. Maybe you've already done some of the questions if you've been playing along with the worksheets. But there's a point somewhere in here where we decided not to use them for the MAT Livestream sheets. I think it's around 2014, 2016 we drew a line. We might have put some 2017 ones on the worksheets. The more recent ones, you haven't seen those questions yet, unless you've been going to look at past papers already. So you might use that information. You might save, I don't know, maybe a couple of them. You might save as ones where you feel like you haven't seen the questions yet for later on. Because I think later on you might want the experience of trying to sit down and do a whole exam all in one go. I don't think that's what you'll do straight away now. I don't think that you're going to do this as a series of separate 2.5-hour practice exams. I think probably what you might do is dip into different past papers, like we've been doing on the show, and see what's there, and find some questions. Yippee, questions. Maths questions, smiley face. Hooray! So you're sort of grazing from various papers and seeing what you can see. Personally, I wouldn't time myself to start off with, or have any concept of whether I was doing things within 2.5 hours. Closer to the exam, I might start to think about how do I want to break this down, bearing in mind that for most of these past papers, the format is different. There are fewer multiple choice questions than there are on the 2025 test. But I think to start off with, I would graze through these, looking for interesting questions, or looking for things where I think, I didn't know they could do a question like that, or maybe I wonder what they've done here, or I can sort of see what's happened. Maybe you look at a question and you realise you kind of know what's going on. That's a good feeling to have. Or maybe you look at the questions and you think, these all look impossible, which is also a normal feeling to have. Right, yes. A quick glance at chat. What's chat saying? Yeah, I'm going to get onto the feedback column as well, Eliza. And the trapezium rule will come up in a second. And yeah, so people are also asking about scores that they should be getting at the moment, and I don't really have a concept of that. So yeah, I don't really have a concept of what score you should be getting. In some sense, I'm not even sure it's helpful information to you yourself to mark your own test. I sort of think also marking your own test is quite hard. We'll talk about solutions in a second. Yeah, cool, okay. So it's tempting, I think, to say the next thing you look at is the solutions, because that's the next column, and maybe some people will just go and look at the solutions. My personal recommendation is that you should not look at the solutions, essentially ever. I think I am a bit radical on this, and I think it is good, probably, that we release worked solutions for these questions as well. But in some sense, if you can't do a question, then I back you to eventually do it. But if you're stuck on the question now, you might not be stuck on the question if you just keep thinking about it and take a break and then do some more thinking about it later, or next week, or a month's time or something. You know, maybe you'll be waiting for a bus in 2 weeks' time and you'll have an idea about quadratic equations that you hadn't had before. And you kind of rob yourself of that experience if you've already looked at the solution and seen, it's something I've never would have thought. That's what people say. They look at the solutions and they say, I never would have thought of sketching the quadratic or something. You kind of think, do you know that? Do you know that you would never have thought of it? Maybe a couple of weeks later, waiting for a bus, you'd have thought of it. Which obviously is not very helpful in an exam situation because you can't get out and wait for a bus and have the idea. But I think the only way to get better at getting unstuck on problems is to remain stuck on them. Sorry. So these are here. And I am being a bit radical. I think people do look at the solutions, partly to find out well, partly they want to mark their own work, I think, and partly to find out maybe whether they've done it the way that Oxford was expecting it to be done. Please don't take it too seriously. If you've done something different from the thing that is in the solutions column, please don't take that too seriously. There's often more than one way to do these questions. Marking is quite generous. If you've done something sensible that's permitted by the question, then marking is usually quite generous in that direction. Yeah, how do we check if our answers are... Yeah, it's a good question from Anonymous in chat. Let's put it on screen quickly. How do we check if our answers are correct if we shouldn't look at the solutions? And the thing I'm trying to aim for here is that you should kind of know. You can even go back and check your own answer, or think of a way to check your own answer. Of course, in the real test, you're not going to be able to look at the solutions. So kind of that shouldn't entirely be part of your process for checking your answers, right? Ideally, you would invent your own ways of working so that you kind of know whether you got that one or guessed that one, whether you did the quadratic formula correctly or not. You should have some way of checking. And for some questions, you can just go sort of check your answers somehow. And for some questions, you kind of don't know, and you do want to go and look at the number in the solutions. I think that's fair enough. But I don't think you should be going there to check, you know, I've had this idea to sketch the quadratic, I don't know if it's going anywhere. I don't think you should go and look at the solutions to find out. I think you should sketch the quadratic, see what happens. Oh dear. How would we, yeah, so Anonymous at the top here, going in now. How would we self-mark the longer questions if we get the final answer wrong, but you don't know? Yeah, I think this is sort of impossible in a way. You just don't know what the marking team would have done that year. Sorry. I feel like you'll know, I think yourself, if it was a kind of small mistake. It's quite hard to know whether you've kind of fundamentally misunderstood the question, and that can be a thing where you've had a go at it. And maybe even my radical position is, once you've had a go at it and you think you've understood the question and had a good attempt at it, then I think looking at the solution is okay, and might even reveal that you, I don't know, sort of misread the question. But if that's happening to you a lot, then I think you need to have two attempts at the question and make sure you're reading it differently. It shouldn't be the case generally that you think you've done a question, look at the solution and see some totally totally unrecognizable different thing. That would be a sign to me, I think, that I was misunderstanding things. I don't know. It's quite hard to detect. Other resources. Yeah. Oh, right. Oh, I didn't see that one coming. I didn't see that one coming. That anonymous question is there still a point for doing questions 2 to 4? And they want to do questions 5 to 7. I thought I was going to do this the other way around. Because in the past, what people ask me, maths students would say, is it worth doing question 6 and 7? And I would say yes. And computer science students would ask me, is it worth doing questions 3 and 4? And I'd say yes. I sort of think all of the questions have got value. Right. For Zach at the top, some of them are worth 2 marks, some of them are worth 3 marks, some of them are worth 4 marks. They always say on the question for the multiple choice questions in MAT 2025, it will say on the question, and those numbers will add up to 70, because that's how many marks the multiple choice section is worth overall. Yeah, and for multiple choice questions, it is all or nothing. You get the marks or you don't. If you are correct, you get the marks. If you don't answer it or you're wrong, you don't get the marks. Sorry. Someone in chat says self-mark harshly, which I don't know. Fair enough. Okay. Oh, that looks serious. The Pearson centres for MAT near my city, here it is, are fully booked. I chose a centre very far. Can I change my test centre? You can keep looking for test centres, I think. If it's a technical question about how you actually change or how you do the search, please ask in the there's a support thing within the test booking page. Please ask them about technical things about rebooking if you want to rebook. Right, okay. Is the multiple choice similar to TMUA? Right, hi Riley. There's always 5 options for MAT 2025 multiple choice questions. Previously it used to be 4, now it's 5. I know that TMUA do something strange where it's different for different questions. We're sticking with 5 for each question. Cool. Bit confused how much working out I'll be able to do. Yeah, so if you look on the tests page, or the MAT page, which links to the test page, there's more information about what to expect in the test centre. Should we do it now? Let's do it now. How do I do that? I've got a bit, oh no, not that one. I need to go over here. I had a plan, I was going to tell you more about these things, I'll come back to that. Here we go. Yeah, I was going to show you these notes for past papers. We'll come back to that. Okay, so on the MAT page, the one with the coffee cup, there are lots of questions about what to expect in the test centre. I'm going to point you to our general tests page, which looks like this. You can probably find it by searching for Oxford admissions tests. This has got separate subpages, so confusingly, they've also got a page about the MAT, fair enough, I suppose. And that has information about booking. I'm leaving all the booking information stuff to the central university who are managing this for all of the Oxford tests. There is some stuff in here about how to register and book, some videos and guidance and FAQs. There's a section on what to expect on test day. There's guidance from Pearson VUE, rescheduling policies, centre management. So I think lots of questions that people want to ask me in Slido chat are possibly on this bit of website. If you want a short URL to just get to this sort of thing, well, I think the shortest one to get to literally the page on screen right now is just ox.ac.uk/MAT. Yeah, there you go. That gets you to the sort of central university MAT page. It's a bit confusing, isn't it? There's a central university who are in charge of all test booking for all the Oxford tests and things like that. And there's also the department, here we are. We look after all the past papers and lots of other resources like this live stream. Hello. Right, good. Okay, so I sort of think lots of the test centre stuff, I'm not a specialist on Pearson VUE test centres, and I think you're better served by having a look at what's out there on the web. I'm going to go back to the safety of my website if I can. Yeah. Oh, do we want to learn about other tests quickly? Oh, we can learn about the classics. No, let's not learn about classics right now. Good. Nope, that one. Yes. Okay. Are the questions weighted differently based on what you're applying for? No. You get marks for the marks are shown question. View science is very mathematical. Good. How do multiple choice questions compare? They're pretty similar in style, which is the important thing, I think. You're doing past papers, not really, I would say, to judge your own ability, because that's really hard to do, and I'm not sure it's that helpful anyway. I think you're doing past papers to get used to the style of the questions and to get used to solving the questions. How many marks they're worth is kind of a separate concern about, you know, how much rewards do you get for doing them, which I can see is kind of relevant if you're planning out your time, perhaps. But I think you're doing past paper questions partly to get used to just doing maths questions, which is why one of my recommendations later on is going to be looking at other maths questions, for which you get no marks on math because they're not math questions. But I think there's value in that as well. Yes. Yeah, I think that's what you get as well, or equivalent. Other brands are available, I think. Yeah, good. Cool. Right, okay, where was I? Oh yes, we're looking at resources. I'm going to hide chat just for a second. So we had questions, hooray. Answers, which I think could be helpful, but they're maybe not as helpful as you think. There are these average scores, which are there for an indication of how things went when that cohort took that test. The first number is the average score for everyone who did the test, who was applying for maths and stats, or maths and philosophy. The second number is the average score of people we shortlisted, which is always higher because MAT is one of the things we consider when we're shortlisting. And then the third score is the average score of everyone we made an offer to, because we're still looking at MAT, but we're also looking at interview, and those things are correlated anyway. So after that, we've got interview scores and we've got MAT scores, and we're going to look at all that. And we publish the number so that you can see that if you've got 80 on a MAT test, then you've done quite well. And it's usually about the same. I kind of inherited this table from the previous admissions and outreach coordinator. I'm not certain why we do 3 significant figures. because I'm not sure there's that much information in the third significant figure, but there we go. Right, okay, so yeah, you have some sort of sense of looking at the past papers. I think the reason you might look at this is partly to feel smug about a paper you did well. You know, average score out of 50.8, I've got 50.9, you can feel smug about yourself, of course. But also you might look at this and think, the 2020 paper just seems a bit like, seems the scores are a bit higher on that one. Maybe something happened. What was going on there? So if you do that paper, you might think, okay, I got a good score. Maybe that paper was just a little bit easier. Who knows? Or maybe not. So these numbers don't really mean anything in terms of comparing different year groups against each other, of course. I don't think you should look at this and say, wow, I wish I'd applied in 2022, because, well, you can't anymore. I definitely don't think you should think if that says anything about the intake. It's just different questions, isn't it? That was obvious, wasn't it? Right, okay, if you want these numbers for computer science for some reason, there is also a link to see those numbers on computer science. I'm still going, because feedback has got more stats. So if you want more statistics, there is more stats in there, including the slightly infamous histogram charts of, are they bar charts? I think they're bar charts. Slightly infamous bar charts of MAT scores. So breaking this down a bit more into a distribution. Okay. The thing I want to highlight, which I'm not sure everyone gets to, because I think some people just look at the questions and solutions, glance at this, and then go to the next one. The thing I want to highlight is the notes column. Maybe people are already looking at this, but we added this quite recently by request. Somebody wrote in to say it would be good if you did this. So we did it for them, but it's also there for everyone, right? The notes are usually descriptions of past questions that wouldn't quite be the same if we set them this year, which is usually because they were written in radians, and questions from 2018 onwards have been written in terms of degrees. So if you want to see that, then there's quite a lot of notes included, especially from 2018 and backwards. So for papers before 2018, we changed the syllabus here between 2017 and 2018. So if you're looking at past papers before then, which you might do, it's what we're going to do when we start going through past papers, we'll notice that some of the questions involve topics that aren't on the syllabus anymore, which means that we wouldn't set them anymore, or at least not exactly the same. I've got some examples below. And this might come up because you might just click on a test paper and have a look at it and think, oh my goodness, what's going on here? We're going to simulate that in a second. I'm just going to catch up on chat. If you're taking MAT and Tamura, how should I distribute my studies between the two? There is massive overlap. Good news. You are studying for both, I suppose. Tamura is one of the things I might suggest is also good for other maths questions. So TMUA is another maths test. It's got tricky maths questions on. I mentioned it before. Okay. Process eliminated, good. Process of elimination is reasonably good. Some questions you can only do by process of elimination. There's one we tried a few weeks ago that said, which of these numbers is the largest? Which you're going to have to eliminate them. It's a reasonable strategy for some questions, I think. Normally the reasons many people with high MAT scores have not been shortlisted. I'm not sure I agree with that. Maybe that's true. Yeah, I'm not quite sure I agree with that. Quite a lot of people have high MAT scores and are not shortlisted, just because there's quite a lot of people. It's not just MAT score. We do look at the rest of your application. There are applicants, let's say, I don't know, let's say you've already done maths at university, probably expected to do better than 70 on the MAT. I'm not saying that's a normal thing to have happened, but it's a thing. Whereas the MAT score is out of 100. You cannot get, yeah, okay. The 50.9 was a joke about self-marking. Okay. Yeah, okay, so easier, harder paper. I'm just catching the chat. Which college should my son go to see the Wren Library? That's at Trinity College, Cambridge. Yep, 2 times 15, let's put that on screen. Somebody's doing the maths in chat. Last year, 10 2 marks, 10 3 marks, 5 4 marks, 2 15 marks. These are the long questions at the end. I'm not sure we've committed to doing this every year, but that was what happened in 2024. 10 10 5, 2 of those. I don't think we've promised to do that every year. That is one way to get to 100 total, which is what it's at. Good. Okay. Good. Okay. Right. Are there any other tests that are like the maths? Well, there's STEP. There's AEA. People sometimes say, which is Advanced Extension Award. Although it is a bit different. It's a bit closer to A level. So I don't know if you want something in between. That's probably cheeky of me to do. AEA. Mention AEA. Or to say that it's in between. But there we go. Right. Okay. We're going to have a look at some past paper questions and talk about what it's like looking at past paper. Are you ready? I think so. Right, well, I already did the distribute your studies between the two. Goodbye, chat. There is massive overlap. Okay, past paper looks like this. I mean, this is an old one. This is from 2008. Wow. I've learned not to ask whether people were alive in 2008. I can count that now. Oh gosh. Oh no. Right, 2008. Here we are. Don't worry about this. This is a hangover of paper marker. Oh my goodness, look at all this. Office use only. Good times. Don't worry about this. There's old past papers. You'll see a page with a grid on it for multiple choice questions. Amazing. These days, you just answer on a computer screen, so you get the options and you click on the radio button next to the question you want. It's quite self-explanatory, really. So maybe we're looking at past paper like this. You'll see a question about cubic, and you'll think, aha, I know what to do with cubics. And possibly there's a mode here where you read through a paper and you just think to yourself, do I have any ideas for how to do this? Which you might, or might not. Either of those is fine. You might move on. So I read the question and I think, yeah, I've got an idea. I know about stationary points. I'm supposed to differentiate, aren't I? And then maybe I'll differentiate it and I'll see what happens. Advanced mode is you realise to yourself, once I've differentiated it, I'll get a quadratic, and I know lots of things about quadratics. So I'm probably going to be okay. Question 1A is often like that. First question. Then we get this question that I think we looked at before about the smallest of these values. And we get this thing. Oh, right, okay, this one is, and you'll notice this quite a lot looking at old past papers if you do, it's in radians, in the sense that this would now say 360 degrees everywhere. So that's the sort of thing in the notes column. There is something which says, oh, by the way, this question would now be written in terms of degrees, which usually means that. And then you get down to this question, D, which I think it's possible to think about this question, even if you haven't seen the remainder theorem. But of course, if you haven't seen the remainder theorem, then it's quite hard, because this question is written from when there was this thing on the syllabus called the remainder theorem, which I've said it 3 times now, but possibly you've not heard that before today. And that's okay, because the remainder theorem is no longer on the syllabus, which means that we can't ask that question this year, or at least not quite like that, to ask you about this kind of polynomial division with a remainder, because we're not allowed to assume that people have seen the remainder theorem anymore. For people interested, it used to be the case that A-level students would see the remainder theorem before the MAT, and now it's not the case that they see it perhaps at all. Some people leave school without ever learning the remainder theorem. I hope that there's someone out there who is currently Googling remainder theorem to find out what this mysterious theorem is that might help them with interesting questions. Goodness knows, maybe I have tricked someone into learning maths today. Anyway, all I'm saying is, you could maybe think about this. What would it mean to divide a polynomial by another one? And what would it mean for there to be a remainder? And how would I work with that remainder? And actually, I think, in some sense, thinking about that might be quite useful, or might be quite sort of interesting to you, to be really stuck. But I don't want you to be upset that you're stuck on question 1D, because possibly the reason you're stuck is you haven't seen the remainder theorem yet. Do you see how it's hard to like mark your own work or to time your own work, right? Because you're going to hit questions like this where, no, these days I can't do that, or at least I can't do it as question 1D like that. So there you go. Did I mention yet which long form questions you focus on? It's going to be all of them when I get there. I think it's going to be all of them. Yeah, so question C, what was question C? Oh, this thing up here. Oh, I think it's kind of geometry question. Maybe it's simultaneous equations actually. Oh, it says simultaneous equations. Maybe it's kind of algebra geometry. Fair warning, lots of mathematicians are quite interested in the intersection between algebra and geometry. It's how we've written a lot of these past math questions, is taking algebra, geometry, mash them together to give you this thing which is on the board there, is algebra. You're probably going to plug one of those equations into the other to try and solve it, but it's kind of also geometry a little bit. I think something might have been rotated, and maybe not. No, it might have been rotated. You're not supposed to. That's fine. Everything, all the questions are in degrees. Can I show you the notes page really quickly? Let's just have a quick look at the notes page. Oh, I keep doing that wrong. There we go. So on the notes page, it's all one page, but it links you to the right place. The notes page is, let's scroll down a bit, back here, it's almost entirely, this question was written in terms of radians. This question was written in terms of radians. This question was written in terms of radians. This has various effects. Like sometimes you look at a past question and it's possible that if we rewrote it these days, we would be able to rewrite it using degrees, and very occasionally the question is just broken by trying to change it to degrees. I think the only one I can think of is this 2010? Ooh, no, 2010 is the funny one. What's the one that says bit of a mess? Oh yeah, it's 2010. So 2010 says this is written in terms of radians. You could redo it all in terms of degrees, but it's a real mess. I think that's the only one which says this question will probably not be set with the new syllabus. It's also the one with a note about the years on it, because the question refers to the last date before today, and at some point in the distant future that will change. I was quite pleased with myself for the notes on 2010. Notes on 2010, this one's a mess, this one is in the past. Ooh, and that matters. Factor theorem is on the syllabus. You are supposed to know the factor theorem, and the fact that you've asked about the factor theorem makes me think that you've heard of the factor theorem, so good news. People are telling me how to do the questions. Good. There are 31 instances of this question was written in terms of radians. Thank you, Avni. Quick, chat is really going for it today. Thank you, chat, this is useful. Does choosing a more popular college make you less likely to get into the university overall? For Oxford, this is my job, was part of my job. I mean, this is part of my job, but part of my job is to make sure that whichever college you apply to at Oxford for maths, that if you're good and you deserve a place at Oxford, that we try and find you a place at some college. There are lots of steps along the way, in fact almost continuously, because we put all of our applicants in the same shared database so that tutors at all of the colleges can see all of the applicants. There are lots of steps along the way where we're checking to make sure that we're taking the best students overall, not just the best students who apply to each college. So if you've applied to a popular college, then well, they might just take you, but other colleges might take some of those students as well. So if next year all of the best candidates apply to the same college, we're fine. We've got some processes to deal with that. Not all of them will go to that college. It seems quite extreme, don't think it's going to happen, but we've got, to a lesser extent, some normal things for moving people around. Cool, right, a bit of chat lag. I don't know what someone says thank you, but I don't know what they're thanking me for. Time to worry about trapezium rule. Is this on here? It's on the screen. It's on the screen. It's on the screen. There it is. No, don't worry about the trapezium rule. I was going to show you this one, 1F. So this one is a little bit more obvious when you're reading it. If the trapezium rule is used to estimate the integral, and you think, oh, what on earth is the trapezium rule? Because the trapezium rule is as of 2018, oh, how do you spell 2018? There we go. As of 2018, trapezium rules not on the MAT syllabus either. These are all things where it used to be the case that we could assume that A-level students have seen them, not anymore. On the MCS course, it says 1% of applicants accepted to a different course. Occasionally, for maths, computer science, there is occasionally sometimes, 1% is pretty low, people get offered a different one of those three. And a little bit in other courses as well, but really not very much. But for maths, computer science, sorry, I don't mean that a maths student might be offered computer science. I don't really mean a maths student would be offered maths and computer science. What am I talking about? Let's say it's a maths and computer science thing. For maths and computer science, sometimes those students are admitted for either computer science or for maths. Depends a little bit on what we think they're really good at. Do I do a live stream for other universities? No, sorry, just this one, plus my personal one. Trapezium rule is needed for TMUA, says someone in chat. Thank you, that is good for me to know. So if you're getting ready for both, then there is some overlap, but not total overlap. TMUA would like you to learn what the trapezium rule is. So have fun. It's not that hard. You can learn it now if you wanted to. Take your function, put some trapeziums underneath it. You know how big trapeziums are. You do know how big trapeziums are. Don't. You do. A trapezium is a rectangle and a triangle sitting on top of each other. You'll work it out, it's fine. So you have these like points. I don't know what to call these. I guess they're between 0 and 1. Worst diagram ever. Between 0 and 1, so maybe 10 intervals, right? I guess we know 10 intervals, 1, 2, 3, 4, 5 shown in this picture, split it up a bit more. So you know what these values are. That's the trapezium rule. Well, there's some formula for what you get when you do that in general, for a general function f, but that's kind of it. If you know how big a triangle is, you can probably work out the trapezium rule for yourself. Gosh, that's not great advice in life, is it? If you know how big a triangle is, just make it out of triangles and add up the triangles. It's silly advice, really. Sorry, I'm grinning because that is how a large chunk of differential geometry. And never mind. What other things, apart from radians and trapezium rules? So in 2018, other things. Here's the note that we put up in 2018. We removed remainder theorem, radians, and the trapezium rule. And I get lots of questions about radians. I never get questions about the remainder theorem, and I very rarely get questions about the trapezium rule. It's the year we added combinations of binomial probabilities. So these questions about choosing. The derivative of e to the kx, I really don't know how we were managing before that. Differentiation from first principles. I didn't say that right. Differentiation from first principles. And the graph of logarithms. And we're going to keep doing sequences and series. There was a point where we started to brief people that some changes there. It's BA for boring historical reasons. Oxford is just like that. Oxford does a BA degree for almost everything. And this is not a disadvantage in the workforce, that people just seem fine with it. I don't know if it's radians for Tamura. It could be, couldn't it? We should probably go and have a look. Somebody has helpfully put, I want to believe that they've just invented this. I want to believe they've just invented it. They've put 4 question marks on it. I think it's correct. I think they've added up all of the triangles and all of the rectangles, and I think they've got the trapezium rule. H is the width of the intervals. So if you're playing along with triangles, that's the sort of base of the triangle, and then there's a change in the y value, which when you add them all up, you end up with something like this. I think some people usually learn a rule for how big a trapezium is, and they kind of forget that it's just a rectangle and 1 or 2 triangles. These are easy trapeziums as well. They've got rectangles at the bottom. Yep. If I could add one thing, what would I add? No, I shouldn't say things like this. ChatGPT taught you this. Cool. Okay. Right, good questions, thank you. I've zoomed in on questions that we're skipping. So some graph sketch questions. We do like these. We've seen some of these before, haven't we? Where you choose one of the graphs. This one's got 4 with pleasing symmetry. These days things have got 5 options, which tends to break symmetry like that. questions tend to get harder through the paper, and then if you're looking at long questions as well, the past papers have got loads. So you can use loads of past paper questions. We've seen this one before, haven't we? It's one of my all-time favourites. So my recommendation is that you should look at all of them. I am going to scare people by looking down at this computer science question. That's my example of a long question. Even though it says at the top for applicants in computer science only, we used to have lots of rules about who should do which questions. So if you were applying for computer science, you would be told to do specific questions in the old days. These days, everyone does the same questions on the maths submissions test. And my advice is that you should probably ignore this. You're just doing this to practice being stuck, right? And the computer scientists don't know any maths that you don't know, do they? I'm not sure. We should ask some of them. Any computer scientists in chat, if you think you have secret knowledge not available to maths students that might help you with this question, or not, just other secret knowledge that you think you've got, then please do share in chat. And if they can't think of anything, then we're going to have to admit that this question could be done by maths candidates as well. I mean, it wasn't, but you know, dabble, you know what a computer is. That doesn't seem to be totally irrelevant for this question to know what a computer is. There's something going on there, isn't there? Yes, okay. So binomial probabilities, by the way, are the ones where if you toss 5 coins, each has a probability of 1/2 of heads, what's the probability you get exactly 3 heads out of 5? And it's something like p to the 3 p q squared, p to the 3 q squared, and then there's a factor of 5 choose 3 to allow for which of the 3 coins it was. It's in there, it's called binomial probabilities because there's a success failure thing going on, and because the answer for the probability involves the binomial coefficient, and that's not a coincidence. Good, okay. You're not given an equation sheet for the maths submissions test. You're supposed to know how to solve. I mean, what would you want? Quadratic formula? No. Some of an arithmetic progression, I guess you might want. Some of a geometric progression. I'm afraid we're asking you to be so familiar with those things that you just know them. I'm reaching for the flashcards. If you would like to practice, we've made some flashcards for you to practice. Well, not just that, but also, which flashcard am I going to show you this time? It's this one. It says y is x to the a. What's the derivative? I think that's in the formula booklet if you do A level, I think. But for us, here's a more plausible one that you might need to memorize. It's the sum of a geometric progression. And I'm afraid you just need to know these things on the syllabus. If you'd like the flashcards, they are on the MAT website. If you go to the MAT Live page, which is there, there's a link to get a copy of flashcards if you want. Not everybody's a flashcard kind of person. Good. Do you have a recommendation for solving techniques? So I was going to give you a reading recommendation first for how to read questions. This is based on the idea that you might read the question before doing it, or maybe separately to doing it. Maybe I can't get people to do the computer science questions, but maybe I can get you to read the computer science questions. Because I think we might learn a bit about the way the questions work. And problem solving is going to be a little bit working out if you can use previous things or trying to get to grips with the things in the question. I feel like I'm always encouraging people to mess around a bit and to just try stuff, even if you're not getting any marks for the messing around, trying stuff, because I think the messing around, for me anyway, helps me get to grips with what's going on. Like this question is going to start by giving us a big definition. There is lots of reading to do. I don't know if I'm a little bit embarrassed now that there is now recording on YouTube forever of me describing that as lots of reading. Yeah, probably the English language students are going to find this video and laugh at me. But there you go, there's lots of reading for us to do. Poor mathematicians, we have to read all of these paragraphs. There are technically 5 of them there for us to understand what this new thing is. So there's a new object, which is a sequence of letters A and B, with some rules. So we've got to read the rules in order to find out what's going on. And then I think I might mess around with these just to get to grips with them. I'm probably going to read the question first to find out what sort of things we're being asked about. But I think I might do some bits and pieces to try and find out some things. There's an example here in the question, which happens sometimes when they've defined a new thing. I'm going to give you an example. And there's some questions. Okay, we're going to read this together in a bit. Is it ever possible to switch from maths to maths and CS after you arrive? It's not automatic for that pair of courses. The only one I can advertise is maths/maths and statistics, which is advertised with a slash. And for that one, during the first year, people can make their minds up and they decide at the start of second year, more or less, whether they're maths students or maths and stats students. Otherwise, it's not impossible as a rule, but it always needs permission from the college that you're at, which means it's not automatic. So it's not banned, but it's not automatic either. And it's sometimes quite hard because you have to catch up on things that you haven't done. We have to use integration by substitution theorem when computing integrals. You're allowed to believe that as long as you follow the instruction in the question, you can do whatever you like, so long as you follow the instructions in the question. The questions are kind of specially written so that you can do them with the syllabus maths and that you don't get an advantage for knowing things not on the syllabus. But you can do that if you like. Here we go, right. Right, the knowledge is coming in as well. Sorry, chat is a bit behind. Breaking problems down into trees. Boolean algebra sounds good. I know, not certain I know what that means. That one, you get a point there. You do not need to know category theory. The binary is not. I don't know what they know about binary, but I'm not sure it's that. Okay. Not sure it's all that. If you know what binary is, I think you're equal. Is the Durham website still talking about MAT? I am not responsible for the Durham website. Sorry if it's talking about MAT. You should maybe talk to Durham. They will not receive results automatically, and I don't know how else they're going to get them. Oh, it says here. I feel like this might be. I don't know. Okay. Can you include a rough work section? Yeah, the questions are not really. If we look at last year's long questions, which are on the past paper page, that's not really. I don't know. You can if you like, but I can't really imagine what it's going to be. You might as well just answer the question. Well, my thoughts on the Maths and CS degree is brilliant. It's really good. It combines pure half of the maths degree, which is not what I personally specialised in, but it's a thing that's very popular, with computer science, which is extremely popular. And those students tend to be very interested in lots of very important things. I think it's great. Well, easy question. Right, okay, yep. In the 2008 paper I opened, question 2, using the previous parts, there's actually no use of previous parts. I think there might be. Does Matt help you with UK&T math challenge? I think not much. A bit in the kind of transferable skills, but not a lot, because math challenge has got, if you like, it's got quite a different syllabus. I'm not sure they publish what maths they're expecting to use, but it's not geometric progressions and calculus, is it? Which are things that I've got. What does Rosie say? If you place a less popular college first, as you prefer it, are you more likely to get into that college over others? If you mean over other colleges, yeah, so we treat your first preference as your first preference, and 75% of Oxford MAT students are at the college that they put on their UCAS form. You're more likely to be at that one, but if you're admitted, then 75% is the one that you picked. But 25% of math students are not at the college they put on their UCAS form, and they seem to be finding that okay overall. Usually they make friends at their college that they're actually at, and then it's brilliant. You can figure out which college. Yeah. Good thing I ended up here where all my friends are. Do I have sensible timings? Should we do timings? I'm sort of waiting for people to do this question for me. Hasn't happened yet, but we'll see if people want to do this question. Now we talk about words. But I think my timings, if I were doing this, let's do timing advice. I think I would like about an hour on the 2 long questions. I think, personally. That's not insider information about what the questions are or something, but I think I would like about half an hour on each. And I think I'd like to try and get multiple choice done in an hour and a half. I'm not sure how I'd sequence them. I think I've said before that I might go to the long questions first. Personally, I'm not sure though. I think possibly I would try and just go from the start. I think personally I do about an hour on long, even though it's only, is that sensible? That's a bit overweighted, isn't it? Because 2.5 hour test, I'm only leaving myself 90 minutes to do 70% out of 150. I quite like long questions. Maybe that's a me thing. I sort of think I can do some of the multiple choice questions quite quickly, but maybe that's just a me thing. Right, don't ask me for timings because apparently I've got mad opinions. I asked students this, and back when there were 10 multiple choice questions, students at Oxford were spending at most an hour on those. I think mostly, not as a rule, but more like 45 to 60 was the one they were picking, I think. So students were doing multiple choice questions a little bit faster than you might guess based on the back of an envelope calculation, that number of marks. That was a bit of a long answer, sorry. Does it work the other way? Can you use UKMT for math and do math practice? Yeah, sure. Different topics, but same, like getting stuck on questions. You don't get a second choice. Second choice is assigned by Oxford. So if you're shortlisted for interview, then you get interviewed by a second college, and that's assigned by an algorithm run by that computer there in the corner. So sorry, for second college, you don't get to choose. That computer in the corner chooses for you. Sorry. So you don't get any more preferences. How do you get quicker at questions? I genuinely think it's just by doing questions. Sorry, that's kind of an awful answer, but we've got time. We can do some questions. I think solving out of time, the thing you've said here, I think is key. I think you should keep doing that. And I don't mean the struggle when timed bit. I think you should keep doing that. Solve out of time is the thing I would encourage people to do. Don't look at the solutions yet. Solve it out of time. 2 weeks time, waiting for a bus. Do that. Sounds good. And maths and CS people treated differently. Ooh, correct. Well, I mean, they do the maths. Well, that's kind of fair, isn't it? We treat them separately because they're applying for a different course. We have a certain number of places for that course, and we admit people for that course. So I guess that is treated differently because it's different. Good. Someone says stuck on part 4. Yeah, well, part 4 is the last part, so there we go. It also says explain your reasoning, which we should be talking about. I realise I'm getting quite stuck on chat now. If the MAT score is good, but this is the last one I'm going to pull out just for now. We shortlist people in late November, get the invitations out ready for interviews in early December. I think there are rough dates on the MAT page actually, and we interview. If your MAT score is good, yeah, that's basically all of the people we're interviewing have a good MAT score. Personal statement a bit subpar. I genuinely don't know what that means. I just genuinely don't know what that means, which I think must be good news for you, right? I just don't know what that means. Cool, right, okay. Let's check we've understood the question. Let's read the question together. Sorry, I'm doing question for a little bit now. I've got to do some maths. Let me do some maths. Okay, here we go. So sequence consisting no letters is an Oxford. Brilliant, okay. I guess this is a computer science idea that no letters constitutes a sequence, but sequence with nothing in it, fine. See, if the sequence W is an Oxford, so I have to dig at the computer scientists, right? Is 0 a number? Of course a 0 is a number. This is fine, I'm happy with this. Okay, if I see no letters, that's an Oxford. If the sequence W is an Oxford, then a sequence that begins with A, followed by W and ending in B, written like this, it makes sense to me, A at the front, then W, then B, is also an Oxford. So I already know, aha. Following from here, I had nothing, and then I put A on the front and B on the end to get AB. What else can I do? If U and V are Oxwords, then the sequence U followed by V, written like this, is an Oxword. So I could take nothing, and I've got nothing and I've got AB. So I could make AB with nothing on the front. I'm a bit stuck. That gives me nothing again. So that gives me AB again. Nothing and then AB. I see down here. I could take AB. U and V could be the same. I could have AB followed by another AB. Getting there. And then I could put another AB on the end as well. Oh no, it's not AB. Oh yeah, okay. So I can stick another AB on the end. That's allowed. I'm allowed to keep sticking AB together because U could be the thing I just had and V could be another AB. And I'm also allowed to put A on the front and B on the end. I can use this rule. So I could take this and I could go a different direction. I could go A, B, B. Obviously, and that's this one here. Good. Okay, I'm going to put A on the front, B on the end. Okay, so we've got permission to do different things. We can join these together in different ways. I'm messing around. I see. I sort of forget to do that again, couldn't I? A, B, B, B. I could keep going. Or I could kind of switch. I could do that one, and then I could do A, B, B. I suppose I could put the A, B on the front or on the end. Those are different. Okay. I've seen down here that it says list all Oxwords of length 6. So I'm kind of focusing on finding a few things of length 6. And then when it comes to do part 2, I'm going to try really carefully to be systematic. I reckon that the challenge here is to think carefully about which rules I'm using. Rule 1 doesn't seem that good. That means you can start somewhere, I suppose. Rules 2 and 3, and what order am I using 2, then 3? And when I'm using 3, what are U and V? And if I'm using 2, what's W? It'll be one of the things I had. There might be several possibilities. So I should work systematically, I suppose, to build up over time. Possibly I could think working backwards. Can I work backwards? There you go, there's a general problem solving thing. Can I work backwards? So working backwards would say, if I want an Oxword of length 6, where's that come from? What did I have before? That's quite tricky actually, isn't it? Because, well, if it starts A and ends B, then maybe I had 4 letters in the middle and I put A on the front and B on the end. Or maybe, and the other possibility is a bit harder, if I had Oxword of length 6, then maybe I made that by jamming together 2 things. And that makes me interested in whether I could have an Oxword of length 1 or an Oxword of length 3, because I haven't found any of those yet. And actually part 1 is to say that there aren't any, so that's quite good. Right, okay. So presumably I can reason about these rules to say that the length stays even whenever you do one of these rules. And yeah, that seems reasonable, doesn't it? I can sort of see the shape of the argument. It's going to be if you do rule 2, then it stays even because you've added a couple of letters. And if you do rule 3, then whatever U and V are, if they're both even length, then this thing will also have even length. So that's kind of not too bad. Yeah. Good. Okay. Quick shout out chat because they give shout out to Math Club. Someone with a username I haven't seen in years says that they're 3rd year of CS at Oxford. Hello. You did it. See you around. You should come and say hi in maths at some time. And shout out to Oxford Online Math Club. Thanks. Good. So this is why people were telling us about trees in chat, because I'm drawing this thing with arrows. Computer scientists maybe think about arrows quite a lot. I don't know. I can sort of see that using rule 2 gives you an arrow to say you were here and then you put an A on the front and B on the end. But this is kind of a complicated rule 3 kind of thing, which I've joined it together with other things. So I've got to think about where these things are coming from. Okay. So in all example so far, we've got equal numbers of A's and B's. The point I want to make here is the reasoning similar? So quite often there are questions that look superficially different because they're asking you to do something else. But what's really going on is that the question is trying to find out whether you understood the structure of what was just happening, I suppose. What I mean here is this proof in part 1 that everything has got an even length builds up. And I think you could do something similar in part 3 to build upwards and say, aha. In fact, yeah, every time you add an A, you add a B. And when you join words together, that keeps the balance of A's and B's in the thing that you make. But that idea for how to structure the argument, that we start from nothing and build up, is the same idea that I was thinking about for part 1, where we've got a lead in by being told a fact in part 1. We're told that they have even length. We're trying to show that. So in part 3, I mean, I might look at the words I've got and realise they're all even length. That's not a proof. I think it's interesting that the way you prove that is basically the same as the way you might prove part 1. You could do something quite similar. That, to me, looks like a question where they're testing that you understood what was going on. It's a kind of, why is that a proof? Why does that work? Or just that it works is good enough, I suppose, because now we can just do it again here. So someone asked in chat for the longer questions, and they're asking about describing working out. I think they're talking about this year, not this question, but talking about 2025. And they say, I first wrote the terms out and noted the geometric progression and then. And I think what I'm supposed to say is that the long questions in 2024 and 2025, you can look at the ones from 2024, you can't see the ones from 2025 yet. The long questions are trying to test your understanding and your ability to explain things. So it's unlikely that you'll be trying to explain a complicated bit of mathematics that you've written on the page, because you're not expected to type complicated mathematics. We know that you've only got a standard keyboard in the test center that you're typing with. So geometric series would be quite hard to type. Probably not what you're going to be dealing with. Cool. That's not quite fair. Some geometric series are really easy to work with, and you absolutely could work with them on a standard keyboard. Let's think about that. Yeah, I can work with some of them. Last year we surprised people. What did we do? Did we surprise people? Yeah, last year we surprised people by surprisingly having vectors in a question, which you might not have expected. You might have thought you can't do vectors on a keyboard. We found a way to do vectors on a keyboard. Right. I think 3 is yes. I agree, K. Every time an A is added, a B is also added. We should probably talk about rule 3 just for completeness, but I don't think we're going to say anything very profound about rule 3. I think rule 2 is the one where things might have gone wrong. I guess we could mention rule 1 as well, couldn't we? If you have no letters, that's an equal number of occurrences. Sometimes I like to add things just to make sure I've covered all the bases. In university exams as well, just to make sure I'm dotting all the I's, crossing all the T's. I don't know if I would really mention rule 1 up here. I would probably try to mention rule 3. Anyway, is everything on the MAT spec guaranteed to come up? I think technically no. Yeah, I think technically the answer is no. Yeah, sorry. I think that has to be the answer. Will someone who is applying to maths do the same questions as someone applying to CS? Yes. They do all of the questions. It's the same now. This one says applicants in CS only, but that's because it's from 2008 when we had separate questions for computer scientists. These days, you do all the questions. Ooh, how do you get the thinking process going? That is a good question. I think I'm improvising by nature, but I'm just willing to try stuff. Right, let's do part 4, since people are talking about this. The question has some more reading for us. It says, you may now assume, interesting, so we're being given a fact, can be written uniquely in the form AWBW prime, where W and W prime are Oxwords. So that's got to be relevant, right? They tell us that we can assume a fact. We may assume, you see. It's got to be relevant in this next part. We're going to count them. It's the ones of length 2n. I guess they're saying 2n because it's always even. I'm always looking back up and down. Anyway, find an expression for this thing in terms of, and then they say kind of all previous values. I think we've seen an example of that, haven't we, in a past question when we looked at sequences a few weeks ago. We saw a sequence where it was the sum of all previous values. Anyway, maybe it's this again. Maybe it's the sum of all previous values. So I suppose this is interesting. We're told that it can be written uniquely in this form, where those are Oxwords. I guess my kind of thought is, since it's unique, I'm thinking this Cn plus 1. So this is things of length. I'm going to write out what it means. So W prime is of length 2n. Is that enough? Well, not quite, because that's not quite good enough, is it? I want to say, aha, that's Cn. But I'm suspicious because it can't be that easy, really, to just say, aha, this thing is of length Cn. You just put the A on the front, the B in the middle, and then you're good. And if I think about it, I realise that, sometimes a single word of length 2n, like this, I don't actually know when I look at that word what W is and what W prime is. I don't know where to split it. There are multiple places I could split it. And I get like a bit nervous. I could split it on the left, you see. Maybe W is this, or maybe W is this thing on the left. That it's not just the case that you can take a word of length 2n, stick an A on the front, and stick a B in the middle, because where do I put it? When I look at this, it's not obvious where to put it. So I suppose I want to say that these things are of length 2n between them, and they're both Oxwords. And I think that's true. Whether it's helpful or not, I don't know yet. But I think it's true that this thing, we're talking about things of length 2n plus 1. I noticed there was a plus 2 out here, I suppose. And I have this fact, I'm always looking at this fact that we've been given, that it's plus 2, so I'm looking at the A and the B, and I'm thinking, I suppose, well, how long are W and W prime? What are these things? We've got all these technology about the number of words at particular lengths. Maybe they're shorter, in which case the relationship I'm looking for is something to do with the words of that length compared to shorter words. So I think these are of length 2n between them. I've got to remember that there could be no letters. The divide could go here. This could be W, and this bit, all of it could be W prime. In which case then you would write out A, nothing, B, that word. And there's this word uniquely that I haven't thought about yet, which I suppose means that for each Oxword of length 2n plus 2, there's a unique pair WW prime. So if I count those, the pair WW prime, making sure that the sum is correct for the lengths, if I count those, then I'm told that will be a specification for every single Oxword of length 2n plus 2. Because every word of length 2n plus 2, I've been told, is A, some stuff, B, some more stuff, where the stuffs have to add up to length 2n. But that's just, well, it's something to do with short words, right? I guess they could be different lengths relative to each other, but I've got this balancing act. I've got to write down some sort of sum, haven't I, for how long these words are. Lots of possibilities. It could be 0 and 2n, or it could be, it's always even. So 2 and 2n minus 2, 4 and 2n minus 4, and so on. I guess W could be longer than W prime. I've got the visualization going on in my head now. I don't know if it's helpful. Probably not for you. It's helpful for me. Thinking about the the balance of what the lengths are. So I think I'm going to go for it. I think Cn plus 1 is C0 Cn plus C1 Cn minus 1 plus Cn Cn minus 2 dot 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 plus Cn C0. And I have to explain my reasoning. So some of this stuff I've been saying out loud, I would now have to turn into words and write down some sentences about how the lengths are supposed to add up to 2n, and I'd say why. I had to explain there are several cases for this, and I'm adding them all up because they're all different words that I get out at the end. I think as long as I'm clear about what I'm doing, I'm going to get down to some sort of result at the end. Aha, good. I don't quite understand what W prime is. Yeah, so it's this thing in the definition in here. They've told me that any word can be written like this, where W and W prime are Ox words. And I thought I just have to believe them, I think. I don't really know what W prime is in particular, but if you give me two Ox words, so for example, if W is this one and W prime is this one, then I can go for, then I can build this, right? A, B, B, A, B, B. There you go. Okay, so for this particular one, this bit is W and this bit is W prime. We're told that that's unique. We're not told how to work them out, but apparently if you look at an Ox word, it's always the case that there's an A and there's some stuff, and then a B. I don't know which B, so it's quite hard when I look at this to work out what W prime really is. I want all of these B's? No, I only want that many B's. And then there's B in particular. Hard to say which one, but apparently it's unique. And then a different Ox word, W prime. And the idea for this question is just because we're told that's unique, it always works, always happens, that we're splitting each Ox word into a pair of shorter Ox words. And we can count those with this huge sum for what it means to have two short Ox words such that the length adds up. Well, there's lots of possibilities. In each of these cases, these numbers are huge, and there are quite a lot of length 4 and quite a lot of length n minus 2. You can pair any of those together and make all these things again. So yeah, BA is not an Ox word. What is an Ox word? Good question. It's the thing in this question. It's not. I don't think it means anything outside of this question. It's not a real concept. It's not a real Oxford thing, but it's the thing just in this question, which consists of some A's and B's with some rules about how you made it. Which I would say most of these are not relevant anymore, except I suppose it's relevant that they always have even length. So this is kind of all of. We haven't missed anything else, and I suppose it's relevant that they could have 0 length. I suppose not. Maybe not that. Maybe that's not that relevant. It's just a rule about adding, really. What is this? Last step. What is an Ox word? Is a very good question in some sense. Oh yeah. By the way, this is a thing. You're not supposed to know it, but this relation, we saw it. Didn't we see it in one of our questions on the sequences worksheet? I can't remember. I think we might have. I think we defined it in an example, didn't we? One of the last questions just said to calculate these things. I told you that they were Catalan numbers. I have a whole book on Catalan numbers. I love Catalan numbers. Good. This question is before me, so it's good to see that other people out there also like Catalan numbers. How many marks the last part? I can't remember. Should we look it up? I guess that's a reason to look at solutions. There we go. For old questions, it didn't say on the question how many marks you get. You have to look at the mark scheme. Oh, look, they're using sum noted in fun. 4 marks at the end. And oh, look, empty set symbol. You're not expected to know that. You're definitely not expected to be able to type that. My goodness. What does Ginger Biscuit say in chat? Something complicated. Let I1 OK plus 1 is generated using the rules from OK. Yeah, fine. All Ox words are the union of all of these. Yeah, the set of Ox words is the union of all of the things. Does that work? I'm I'm worried that your sets have overlap, but it doesn't matter because you're taking the union. Yeah, fine, okay. Good, okay. People have probably worked out that I'm not commenting. There's a frequently asked question in chat that I'm not commenting on. Oh well. After doing all math question papers, where should I go next for more questions? That's a good time to ask this question, I think. We've had a look at this one. There are loads more like this. I don't want to spoil them now. We're going to look at some of them over the next few weeks on MAT Livestream after a bit of a quick break. I'm going to recommend some other places for you to get questions. We've talked about this a little bit already. So other tricky maths questions. Sorry for the handwriting. I do like TMUA. TMUA has some guidance notes on logic and proof as well. So if you want some more examples of questions where you think about proving things or some guidance on what that means, they've got some support documents which you could have a look at. There's the thing called AEA, which I mentioned. If you can find past papers, if you can find, let's spell. So if you can find it, there's AEA out there. I really like Enrich. It's not really like a maths test at all. So let's go not a test. Enrich is a website. You can probably guess what the website is, but you're probably going to put it in Google or something like that, and you'll find the website for Enrich, which has lots of different things really, lots of activities and games and puzzles and problems and some classic activities. I quite like it for things that are a bit different. Sometimes you look at a maths question and you think, oh, this is just something else, right? That Oxford question we were just looking at, does it use anything on the syllabus? I'm not really sure. It's sort of also testing your, I guess, even numbers, logical reasoning in some sense. If you want to practice that by looking at stuff that has kind of nothing to do with the maths submissions test, then something like Enrich might be quite fun. I also like Project Euler, but that's quite a different recommendation. That's if you like computers. So Project Euler is a website full of tricky maths problems for your computer to do. You will need to help. You'll need to have an idea about how to do the question. And then the idea is that you write some computer code for your computer to actually do the hard work. That's not what math is like at all, of course. That is really not how maths works. But if you're applying for maths and computer science, then it might be the sort of thing that you're interested in. Sort of problems where you need to look at it, think about how you might approach it if you were going to do it by hand, and then think about how you might get a computer to do it. Lots of them are quite hard just to have that maths idea. I mean, some of them are extremely hard. There's lots of problems there. Any fans of Project Euler? Let's approve it, but then say, no, I wouldn't do that if I were you. I'm really into free resources. £50 an hour sounds like quite a lot. Oh, an Oxford, I missed that the first time I read it. An Oxford student. Oh. This is me. This is the noise of me begrudgingly respecting the hustle. Is that a thing? No, I'm not even sure I do begrudgingly respect the hustle. Anyway. Oh, hello. If AWB is an Oxford, if AWB is then as WB is. Yeah, so I agree it isn't Oxford. It's not obvious to me. The thing that's not obvious, Ginger Biscuit, is that you can write any Oxford like that. I kind of get that they all start with A. Oh, no, okay. So I suppose they all start with A, because what else are they going to start with? When did you get a B on the front? It didn't happen. And they all have a B in there somewhere. We proved that earlier on. So I suppose it's clear to me that you can always write an Oxford like that. The uniquely bit is really interesting. This is not obvious, by the way, I think. Well, I'm not surprised that this is not the question. Can you write this uniquely? Anyway, we're now just having a chat about maths, aren't we? Math chat. Yeah, undergrad maths I also like. Right, okay, we're going to do some website crawling. I think I'm running out of, other than just doing more maths questions, which is just me. I'm going to do more maths questions, you can't stop me. But other than doing more maths questions, I haven't got more planned. Have I? Oh, hang on, I've got some notes. I wrote these beforehand. We're going to go look at some maths questions, but first, here are some final tips. Yeah, final tips. 1. Don't look at the solutions first. I've promoted earlier a don't look at the solutions approach. That's probably a bit too strong, but definitely don't download them at the same time as the questions. Make yourself come back for the solutions at least. Tip 2, don't just do the maths questions. Have a look at the CS questions or just other questions. Practice being stuck on things. You might find that occasionally you need to learn a thing or do something differently. To do like these things on other websites or other stuff, you might need to learn something different. But maybe that's good for you. Maybe looking at other sorts of maths is sort of good for you generally. I don't know. 3, it's not an open book test. You might be tempted when you read a question to go and look up that bit from your notes that you have in school, or look at a textbook, or go and look at the flashcards or something, but that doesn't work in the actual test. There's no equation sheet and you can't look at your textbook. So I think you need to struggle with it a little bit. That might mean reinventing something that you're pretty sure there's a formula for adding all of the terms of a arithmetic progression, but you've forgotten it. I think you should struggle with it a little bit to practice. Could you work that out if you had to? It's good to know if you find that you could work it out if you had to. Good to know. But then also afterwards, when you're done, or if you give up, then you could go and look it up. But make sure you only do that when you're looking something up because you need to know it. It's not an open book test. 4, don't worry about timings or marking. There's people in questions. Should you mark questions as you do them? I would, if you're going to mark them, I would only look at them once you're done with a question, because when you download the solutions, you get all of the solutions for that paper. So you can't like do one of them and try not to look at the next sheet. It just feels messy. I would only look at the solutions document when I'm done with a year, I think. And I'm not certain that I really encourage it that much. Other than if you want to find out how many marks something was worth, or check what other solutions might look like, if there are any. And I think last one is do something else as well. Up to you whether that means more maths. We're going to look at some now. Or whether it means do something else entirely. I know some people don't have a choice because you've got other things you've got to do over the summer. And I sort of think some of that is good in the sense that probably staring at the question and forcing yourself to think for an entire day is probably not good for you. And maybe taking a break and think about something else. Now, in the actual test, that might mean switching to a different question and coming back. You might like to practice that sort of thing. You might never come back, I suppose, while you're practicing. Some sense. Being stuck on the question and staying stuck. Good for you, I think. Okay. I sort of agree with that. The 50 quid were not keen. I regret even considering whether I respected the hustle. I think I've decided I don't. Okay. Very good at interviews. Okay, cool. Now the interviews are also maths. If you think you'd be good at a maths interview, then use some of those maths skills. Right, yes. This is very gentle. How to practice math questions is kind of my job right now. I've set up a live stream called Past Paper Guidance. Here we are, we're doing past paper guidance together. I don't think I'm spoon feeding people. Oh, just on your phone, no paper. What we're going to do, I think you're going to look at the question and you're going to try and work out what to do. And there's a good practice for your visualization or whatever of what might be coming next. Like that cubic we looked at, where we thought, yeah, you should probably differentiate this. and you'll get a quadratic, and then you'll try looking at the discriminant, and is it positive, is it negative? You'll decide how many solutions for how many turning points there are. Because we're being able to kind of see through the steps. Sorry, I've got quite a visual way of imagining things. Not everyone does, I know, but for me it's sort of imagining what it's going to look like when I write it down. That's probably quite good for you. Didn't someone tell me this once, that they had to do past papers on the bus home? It was a really long bus home, and they couldn't, I'm sure someone told me this, they couldn't write anything down while they were on the bus, and it was a really long journey, so that was like their time for looking at past papers. And it was surprisingly good for them because it made them actually think about the questions rather than just, doing whatever. Actually accidentally trick themselves into being stuck on questions and thinking about what might happen. I'm not speaking for people. Good, right, okay, we're going to do some enrich. I'm going to get post 16, but some of this stuff, even like primary stuff, I'm not in primary school. I think some of this is actually quite good. I'm not going to say all of it is quite useful, but I think some of it you'd be surprised. What am I looking for? I would like resources linked to the UK A-level curriculum. Let's see what we can find. I think I'm going to go pure maths for this one. I think I'm going to go for differentiation and integration. And then quite quickly we're going to get to stuff that is not on the MAT syllabus, but is going to be fun. Let's have a look. All right, okay, here we go. X of R is defined implicitly by the quadratic relationship. Shall I zoom in a bit? There we go. How do I feel about cookies? I think. Here's the question. Defined implicitly with a quadratic relationship. Blimey. Okay, so it's like a function, but it's got a quadratic relationship. Crikey. That sounds scary, but if I think about it here, it looks a lot like a quadratic equation, doesn't it? It's got an x squared in it. I suppose that's what quadratic relationship must mean. Part 1, which of the choices, if you put r of 1, minus 1, 100, give real values for x of r? Which sounds not that bad, because if you tell me that r is 1, then what I'm going to do is I'm going to rewrite this. It sounds like x squared minus x plus 1 equals 0. And that's a quadratic, and that really is a quadratic, so I can think about quadratics. Part 2, what is the range of values of r for which this takes real values? That's harder, but we've got some data. When we get to part 2, we've got some data. Let me think about that. And actually, if I think about it as a quadratic, maybe I've got ideas about whether quadratics have solutions or not. What happens when r equals 0? What does happen if you put 0, 0, 0? Well, I think x doesn't have any, there's no value of x that would work in this equation if r equals 0, because 1 is not equal to 0. Oh, then we're going to sketch it. We're going to try and draw it. So if I've been paying attention along the way, I should have spotted that they were getting me to think about the values, think about the range, and think about, okay, they're tricking me into getting ready to sketch the graph, and it was all building up to this sketch. Maximum and minimum values of x. That sounds hard. I suppose at that stage I know what's going on. You will need to use calculus to prove it. And I think the calculus you will need is a bit harder than maths, but maybe you've met it anyway. And maybe just sketching it or messing around with it might be fun. Can I do that without using staff? No, I think I do need calculus. I think I do. There's stuff like that, right? Well, that's an idea. It's not a math question, because I think the calculus that it's using is not on the math syllabus, but something to mess around with, isn't it? We can at least do the first couple of parts. Right. Someone is asking a question quite rudely, and I think not keen on that. Should I mark my practice math papers? My hot take is like no, but yeah. Dog says if r equals 0, then 0 equals 1, which I think I have to say there's no value of x that works in that equation, because we're trying to talk about, I guess I'm interested here, like, is x of 0 a thing? Not really. So I suppose this blows up for x equals 0. Is the discriminant of this quadratic nice? B squared minus 4. It's not really, no. Not that nice. Second derivative. Oh, what is second derivative? Oh, right, okay, you could do some implicit differentiation, couldn't you? You could do some... That's not on the math syllabus at all. Why am I talking about it on this show? Anyway, there are advanced techniques that you could use to try and get some idea about what the derivative of this function is, if you want to do. That was just one of them. Why is this called trig? Oh, yuck, look at this, cos of sine of cos, and it's in radians. Can you find turning points? Can you differentiate it? You will probably need to know how to differentiate cos and sine. You'll need to know about radians. You'll need to know about the chain rule. You'll need to know all sorts of maths to do this one. But fun stuff. Some of these problems on Enrich. Some of these problems on Enrich have student solutions, which you shouldn't click until you've had a go at the question. Good. Okay. Other stuff like that is out here. I think I was also interested. That was all differentiation and integration, wasn't it? Occasionally you find a question and you think, I need to make this a little bit harder for myself. There's challenge level 1 star, I think. Large supply of basic vectors like this. Where can you go? B1 vector or B2 vector, or either forwards or backwards. Where can you go if you walk around like this? These are generators. There you go. You can get a little extension into actual maths. Good. Oh, very nice. They're not being, so someone was being rude, but only in, they were cross at the moderator for being moderated, and then I didn't like the way in which they were being cross at the moderator. They're being double moderated. Lillian, if you're watching, you're doing a great job. Thank you. Right. Good. Okay, I think I'm wrapping up actually. So I'll switch to questions. We'll switch to some sort of Q&A mode. Because I've got some time on the clock, but I guess I promise not to do anything unmissable. So if you're leaving now, bye, have a nice weekend. I'll see you 11th of September if you're joining in for past papers. I'm going to start going through 2007 and onwards. I think maybe looking at questions chosen from 2007, 8 and 9 in the first time when we're back in September. The idea is that maybe you can get a head start on me. Maybe you can get ahead of the live streams by looking at past papers, so that when you come to the live stream, if you're here live, we'll do a vote on which questions people want to talk about, which I intend to mostly respect the vote, but maybe choose some of my favourites as well, bit of both. Right, okay. Yeah, some of the coordinates lie. Yeah, it's interesting, isn't it? So 0, 1 is an interesting kind of coordinate. Ginger Biscuit wants to prove the thing from question 7. Is it going to be easy? No, I don't think it's going to be easy. So, because it's the Catalan numbers, my thinking is that the current count is a good idea, I think. Yeah, so some of the points lie on, it's interesting, you can build, so you have 0, 1, that lets you go up, and you have 2, 1, but then you can build, I think, 2, 0, so some of them do they lie on the x axis? Are there points on the x axis that you can get to by walking around like this? Points that you don't get to. You might be interested in the lengths of these vectors, or not. You might not be interested in the lengths of these vectors. I've just realised this one's got length √5, which doesn't feel very relevant. Maybe it is important, I don't know. That's something I might think about, like how big are these steps? Are they huge? I suppose you can come back again though, so there's something going on where you go like big steps that go around in a big kind of loop, and then you magically end up, doing a big loop, you end up at somewhere you never thought you could get to, possibly. It's the sort of thing we should consider, isn't it? What if you do a really big loop? You do some of the B1s forwards, you do some B1s backwards, you do some B2 forwards, you do some B2s backwards. Could you possibly end up at, I can't see how to get to 1, 0 off these. Yeah, I can't see how to get to 1, 0. But maybe you'll tell me that if you do a big loop, then you can get there. Vectors. What did we discuss? We talked a bit about random things. We tried some Enrich problems. I don't think I've said anything useful for about 5 minutes. I'm considering ending the live stream early because I think I'm getting less and less useful. let's just run the clock down. What do you want to chat about? Rosie wants to talk about Zeno's paradoxes. Was that on Maths Club that we did Zeno's paradoxes? Or thought about them a little bit? When was that? I mentioned Zeno's paradoxes to several different people at different times. Learning about infinity. Nice. I'm not sure I know about the origins of infinity. That seems like the sort of thing I should learn about. Do you want to recommend a book? Rosie's reading about infinity and origins. I think I'd like to learn that. What have we got then? Kay's just joined again. Ginger Biscuit is thinking about counts of A's and B's. The A's are already ahead. If you join them together, that remains true. If you put an A on the front and a B on the end, then it gets even more true because the A's are now more ahead. So that's always the case. Which B do you pick out then? Do you pick the point where is it equal numbers of A's and B's? So it's going to be a tie. How do we find that? At some point the A's start ahead because they start with an A. Some point in between, we know that we'll get down to equal numbers right at the end. So somewhere along the way, we have to get to a position where I think we have, not counting the first A, exactly the same number. We have to get to 1, we have to get to +1 again. Maybe immediately. No, something like this. It's sort of like, as you see the A's and B's, it goes up and down. It goes up and down. Have you got more A's or more B's? You've always got more A, B's, so it's always positive. And eventually you get to 0, so you must go through 1 and then choose the point where you get to 1. Something like that. All these Catalan properties are kind of quite similar, aren't they? I'm not that. Sorry, I said that like we all know about Catalan properties. I've just remembered that that's me being very keen on this. Right, okay. What is my personal favourite math question ever? It probably is. Should we have a look? Is it the one that I've got over here? Is it this one? This one is very good. I've spent a lot of time thinking about this one. It's a bit of an all-timer. So it's using the values of A and B found in part 2. So somebody in chat said that the solution didn't use previous parts. I bet it did though. Right, no. I see. I didn't know what to make of this chat comment earlier. Somebody said in chat, the solution on the website doesn't actually use the previous part, and that's just because this is telling us that we're using the values so that xn and yn are actually defined at this point. Because we need to specify it. Over here it's vague. When the sequences are defined up here, they've got these A's and B's in, and then you found the A's and B's, and we need to say in the question that we are using your values of A and B that you found. That is now part of the definition. That is now canon, that is part of what X and Y really are, so that we can ask you questions about it. That's like a follow-on. The setup has a question mark for this A and B. What are these? Okay. That is subtle. That's not quite a like you will need to look back at your working so much as just carry on from where you are. We're playing along with you. Good. Okay. Jacob says thanks. Bye, Jacob. I really like solving maths problems. Me too. The way that you get that feeling, of course, is you have to solve maths problems by being stuck on them and having an idea. That quadratic thing from the Enrich website is going to be the thing I think about on the train, I think. A bit. What am I expecting? Quadratic, what does x of r look like? It's like, if I rephrase it, it's like xy squared. I think I know what that looks like. Well, maybe I don't. When I rearrange it, if I solve the quadratic, I'll get a square root. And I don't really know what's going on from there. I kind of want to Desmos it. I guess I had x squared, didn't it? Because it was r squared, x squared at the front. So like you could do anything, I suppose, in general. Not anything. There's at most 2 solutions for each value of x. There's a graph where you have at most 2 roots. You can do a lot of things with that. If you put different, I'm imagining different versions of the questions with different r's in. Maybe I should have this on the screen while I'm talking about it. maybe not. Sometimes you have to think about different ways to change the questions, which, you know, if you've done a question, you're bored of it. And for this one, I would like to think about other sequences, or let's think about other numbers in here other than -2. Seems fun. You know, the punchline of this is that you've approximated root 2. Can I approximate other things? I remember now on the MAT livestream, we've had some extension ideas. So it's going to stop loading. Never mind. So yeah, this had r squared x squared at the front, and I've been reading it as a quadratic in x. We could also think about it quadratic in terms of r. Yeah, stuck on that question. Which question? Sorry, anonymous person. They say they're stuck on a question. Possibly it's this one, or possibly it's the one behind. We've now got questions stacked on top of questions. I'm being confusing. So this one, I've been thinking of this as a quadratic in x. I think just because x is larger as a shape on the page. You could think about it as a quadratic in r. That's allowed. Does it have any symmetries? Not that I can see. Quite tempting to just put this in Desmos now, isn't it? I'd really like, because in Desmos I like things to be y as a function of x, and sometimes when I'm thinking I like things to be y as a function of x. So in my head I'm translating to have lots of x's here, and then confusingly not x's here, but y instead. Maybe that's an inflexibility on my part to always want x to be the independent variable and y to be the dependent variable. Favourite question, last part. Right. So at this stage of the question, you have got sequences xn and yn that both get very large. You can tell me how large, really, if you have to. I don't think you have to, but you know, xn is doing something like multiplying something by 4 each time. Yn is not insignificant, and being multiplied by 4 tends to make the numbers larger. So they get larger each time. But the thing I want to point at is that these things satisfy. You also know at this stage, I think, spoilers for this question, but I think you know that this is true. So this is quite suspicious. We know that these numbers are both huge and that they satisfy this equation. And this is spoilers for the previous parts of the question, but at this stage you know this. So then the idea is that, well, this doesn't say anything about xn over yn, but it could if we divide by yn. So the idea is to divide by yn squared, so that xn over yn appears in the question. And then this thing on the right hand side is very small. Oh, just off the bottom of the screen, sorry. Behind the website. So the idea is to divide by yn squared so that it appears in this equation. Maybe if you're stuck here, then the punchline is look back at what you were just doing. And if you're stuck here, then I guess this is one of those things where I needed something about xn over yn, so I was willing to do stuff to try and make that appear. This bit's very small, so it must be the case that xn over yn is about root 2. Maybe minus root 2, probably not minus root 2, probably root 2. And in fact, xn over yn, the correct answer is that it's really close to root 2. Because this is so small, then it must be the case that these things almost cancel each other out. 2 bit lost, almost cancel to give 1. That is a joke at the top. The model answer does not say anything like continued fractions. Good. Which is I think quite cool, because then you have an approximation. You've just done some sequences, but you have an approximation to root 2. And if you work out the numbers, you get things like 17 over 12, which is a pretty good approximation to root 2. Yay, we did it. Pell's equation, yeah. So if you want to find out more, you could search for the things in Zach's comment, which is going past Pell's equation, Diophantine equation. If you want to see more things like this, they get extremely difficult really fast. Right, okay. 2014 Q1E. The values of Q for which there is a minimum of x equals 1. Anonymous has put a cubic in chat. Let me highlight it. I think I'm now just helping people with math questions, which is what I want to do. So they've asked for the minimum x equals 1. Oh, is this the question where it turns out to be all values of k? It just always happens that there's a minimum at x equals 1. Let's check. I vaguely remember that being a thing. So I'm going to call this y, and then I'm going to put some words in. So at x equals 1, dy over dx is 3k minus 2. Oh, x. K plus 1. I noticed that there was an x squared and then nothing, and then. I mean, I'm plugging in x equals 1 anyway, so it's quite a forgiving question. Yeah, so then the k's cancel, and the 2's cancel. So it looks like it's the case that for all values of k, I hope that's one of the options. We play with it. Kx cubed minus k plus 1 x squared plus 2 minus kx minus k. Add a slider for k. Here's our cubic. Go. Oh, it's gone off the page. Where's it gone? There it goes. Oh yeah, look, it's always got this line here. It's always got a turning point there. Flipping around shape, but all values okay. But all the ones I've checked in decimals, and whoop, all of the other ones too. Nice. It's a surprising answer, I think, but a surprising answer, but one we should look out for. That sometimes you change k and it doesn't move left or right, just up and down. Oh, right, sorry, it's about whether it's a minimum, so we should check the second derivative. Right, sorry, did I misread the question I highlighted, or was it just not there? Okay. So for minimum, we should look at the second derivative. And that did, in the decimals at least, look like it was changing shape. I'll put this on the screen to make it look like I thought about it. And they say minimum, so I'm going to check that this is positive. I suppose the second derivative, let's come back now. Let's just go. I feel bad now, I skipped part of the question. Well, I skipped the entire point of the question, but here we are. At x equals 1, here we are. Okay, sometimes that's positive, sometimes that's negative, depends on k. Versus a quarter, no, a half or something like that. Not certain I've got my numbers right. Whatever. Good. Okay. I do need to worry about second derivative equals 0. Oh, maybe I should. You're right. Maybe I should worry about that case. Let's have a look. I see the question now. I don't think we use the phrase point of inflection on MAT questions, but at the top, the other things are mentioned in the MAT Livestream worksheet on calculus. Even though look at the other ones. What am I trying to look for? I'm trying to look for 2014 to see what the question actually said. Zoom. The E? What does it say? Oh no, that's trigonometry. C. Has a turning point, comma, that is a minimum, comma, when x equals 1, precisely 4. And there's some range here, but it's excluded 1/2 from this one. I think that's what we see. Oh, I see, and then... so I see the question in chat is going to be... So this is greater than 0 if this is greater than 0, but then the question in chat is going to be, yeah, but what about the case where the second derivative equals 0? Could it still be a turning point, comma, that is a minimum, comma? Oh my goodness. I don't know, let's think about it. So maybe I should put in, I want to go over here. So maybe I should, I mean, I'm not going to really, in the test, if I see this and I get k something to do with 1/2, I'm choosing C and I'm moving on. But you're right, the case k equals 1/2 is interesting. And maybe maybe we should think about what's going on in that case. Have I still got that Desmos? Can I just Desmos it? That's cheeky, isn't it? It's going to be some sort of degenerate case. Right, okay. So cheating, but putting it in Desmos. In the case k equals 1/2, we'll find that that is not a turning point because the first derivative doesn't change sign, which I could maybe have predicted from the fact that the second derivative in that case would be 0, and it's a cubic polynomial, so there's no funny business. Higher degrees of polynomial can do all sorts of stuff, including having lots of things be equal to 0, but then have a turning point anyway. X to the 22 is just like that. Loads of its derivatives are 0. It's got a turning point at 0. Cubic, though, if you know where you are, the second derivative is linear. So I could think about, I should go back and think about the signs of the first derivative and second derivative. Good fun, okay. Cool. Yes, there's a book called Topology of Numbers by Hatcher, which has got lots of facts about that sort of can this expression take these numbers? What's the behaviour when you have large numbers in there? Ah, Rosie's in chat, and that reminds me, I asked Rosie for a book recommendation, and then I maybe wasn't looking if we got a book recommendation. No. Ah, sorry, you've asked this twice. Sorry. Have you ever dealt with anxiety around maths test? If so, how did you manage it? Yes. Second year exams were not fun for me at university, mostly because I couldn't do the fluid dynamics question, and I really wanted to do the fluid dynamics question, and I was quite stressed that this meant that I wouldn't like fluid dynamics, and it was kind of my thing, or the thing I was trying to make into my thing. And unfortunately, the way that I had to deal with it in that situation was just do some other questions and just do as much as you can. I did leave the room and come back in. I think that was good for me. I don't know how that works in Pearson VUE test centres. I don't know how it works. I think I should probably read more of the website. And I know the math seems daunting. The thing I want you to remember when you're doing it is that you can do these questions using maths that's on the syllabus or some logical reasoning. And you've learned that maths when you have logical reasoning. So it's not the case that there's other stuff you were supposed to know. I would just like people to go into the test feeling prepared. I think it's probably good for us. Right. What on earth is that? Am I going to put that in Desmos and it's something crazy, or somehow some sort of computer virus? It looks like a computer virus. I put this in Desmos. Right, cool. I'm not responsible for anybody putting this into Desmos and getting some sort of virus. Ah, it's A Brief History of Infinity by B. Clegg. Thank you, Rosie. It's called History. Fun little math snippets like Converging Series. Ah, cool. Cool, thank you. The new 4-mark multiple choice questions, roughly the same difficulty. Obviously, I can't comment on difficulty of questions. It doesn't feel fair. Sorry, I can't. I think the questions over different years do have different difficulties. Seems to work out though. Average score seems to turn out to be about 50 every year. Right, okay, good. I've read Around the World in 80 Games. That's by Marcus Slido, who's okay at Oxford. Words. Sometimes I feel like, well, so I say that, and then I worry that people write that down and think, oh, he's at Oxford. I should read an Oxford book, but not how any of this works. You should read what you want to read, wherever it's from. Right, dinner time over there. I think it might be dinner time for me as well. Kay asking about critical point, stationary point, turning point, point of inflection. I'm not going to do this on the spot, I think, because there's a chance that I say something wrong or stupid or confusing. I'm going to suggest that you either look at the resources on the MAT Live website or try and find somebody else's guides to A-level maths, maybe try and read a couple, compare them, see what you can find. Sorry. Off the top of my head. No, let's not go off the top of my head. I will say something stupid. The key difference, here, this is safe. The key difference, I think, is what the calculus tells you versus what the actual behaviour of the graph is. There are some interesting cases where you might believe that the calculus always reveals exactly what's going on with the graph, but that's not true in general. Like I said, x to the 22, you can take a dozen derivatives of that and not notice what's going on because you keep getting 0 at 0. But if you draw a graph, then you see what's going on. So there's something going on there. There's some difference between we'd like to describe behaviours of the graph and we have calculus, and calculus doesn't always give us the answers immediately. So there's some difference between those two things. Right. I define maximum as a supremum that is achieved by the function, and I don't think that's a useful thing for me to say. Right, good. I'm going to call it there, I think. Thank you for joining in quite a strange live stream. Normally we just do math questions back to back, and don't worry, that is where we're going with this. That's what we're going to do in September. So I've got 2 weeks off. That's a chance for you to get ahead of me on math questions, but then we're back 11th of September for some more of that. So I'll see you then. Enjoy doing math questions and doing something else, like we said. We'll see you back here for a live stream in about 3 weeks. Bye everyone. Good night. Someone says thank you, Jamie, which I will approve. All right, good. Okay. Bye.